Okay, kiddos, here goes. Video lesson talking about circuit diagrams and how to find these things. Equivalent resistance, current through the circuit, voltage drop across each resistor, and then the current through each resistor. Alright, so let's take a look at our first example. We have a 6-volt battery, and in series we have a 2 and a 4 ohm resistor. So the electrons will flow through this resistor, through the wire, and then through this resistor and back to the battery. Okay, so these are in series because every electron has to flow through each resistor. If we were to look at example number 2, these resistors are in parallel because the electrons can flow through this one back to the battery or this one back to the battery. And the fact that there are two different paths for the electrons to take means that there is going to be actually less resistance in that one. So, first, finding the equivalent resistance. If they are in series, we add them. So these resistors are in series. We are going to add them, and 2 plus 4 is 6 ohms. That is the equivalent resistance of the circuit. For the second part, to find the current through the circuit, sorry, little pause there, I'm going to write this. So, equivalent resistance equals 6 ohms. You're going to have to pardon my messy writing. Equivalent resistance. Equivalent resistance is like the total resistance, or the resistance of the entire circuit. Okay. 6 ohms. To find the current through the circuit, well, we have this much resistance and this much voltage. So we will use Ohm's law, which is V equals IR. Voltage, current, resistance. This would be measured in volts, this would be measured in ohms, this is measured in amps. So, dividing, we end up with current equals 1 amp. And this is current through circuit. Current through circuit. Okay. Next up, we're going to look at each resistor individually. Okay, so because these are in series, and I'm going to draw the current as the way the electrons will. I'm going to draw the current as the way the electrons will flow. So that is this way. Again, this is the negative, this is the positive terminal of the battery. So total current through circuit, we know that 1 amp of current flows through here. We also know that 1 amp of current flows through here. So that's for this part right down here. Number 4, the thing we're finding is current through each resistor. So we could say that the current through this resistor is 1 amp, and we can say the current through this resistor is 1 amp. We know that because if you picture the electrons going through here, right, and then moving along the wire and then going through here, everything that passes through here has to pass through here in order to get back to the battery. So they're going to have the same current, okay? Now, the push on those electrons is not going to be the same. The push, meaning the voltage, right, the push supplied by the battery, some of it gets used up here, and then they flow freely through the wire, and then some of it, whatever remains, gets used up here. So, when we go to find this third part here, the voltage drop across each resistor, that's where we're going to have to consider this and consider this separately. We're going to use V equals IR, Ohm's law. So, we're finding the voltage drop, meaning the voltage used up by this resistor. Current through this resistor is 1 amp. The resistance of this resistor is 4, giving voltage is 4, and this would be volts. So we say that is the voltage drop across this resistor. The voltage drop across this resistor, or the voltage used up by this resistor, is 1 amp times 2 ohms. Voltage equals 2 volts. Okay. Notice how 4 plus 2 is 6. Okay. This is true for a series circuit. So in a series circuit, the current through each resistor is the same. The voltage drop across each resistor has to add up to the total voltage. Alright, parallel circuits are different. Let's move on. Number 2 looks like this. So we have a 6-volt battery connected to a 4 ohm and a 2 ohm resistor in parallel. Parallel meaning the current can flow through this one or through this one to get back to the battery. Not both, one or the other. The formula, or the way we calculate the equivalent resistance, is we do 1 over R is 1 over 4 plus 1 over, and what was that, 2? Yes, okay. So we're going to use our fraction skills. We have 2/4, wait, what? No. 1/4 plus 2/4 is 3/4. And we are going to reciprocate or cross multiply, meaning R is 4/3 of an ohm. Okay, this is the what? Drum roll, please. This is the equivalent resistance. Look at that beautiful writing of circuit. Okay. Notice, please, how that the 4/3 ohm is less than 2 ohms and less than 4 ohms. Will it always be like that? Yes. The fact that there's another path for the electrons to take means the resistance is decreased. Don't tell anyone I'm eating candy while I make this video lesson. Shame on me. Okay. Where was I? I got distracted. Oh yeah, current through the circuit. So, we know the equivalent resistance of the circuit. We're going to use Ohm's law to find the total current through the circuit. Our voltage is 6. Our current is I, that's what we're solving for. And our equivalent resistance was 4/3. Okay, so when I say the current through the circuit, well, let's just solve first. Multiplying by 3/4 yields 18 over 4, which is a 4.5 amps. Okay, so this is the current through the circuit, or total current through the circuit. What this means is the current is going to be going, whoops, like this. So that is 4.5 amps. Okay, the current's going to split. Some of it's going to go through here, and the other is going to go through here. And so you may ask, well, how much? Because this is a greater resistance, less electrons will flow through. Because this is a less resistance, or a lesser resistance, more electrons will flow through. So this current is going to be split up, where part of it goes here, and more of it goes here, but together, those two currents, current is like the amount of electrons that pass through, those two currents will add to equal 4.5 amps. Okay. The other thing about a parallel circuit is that this 6 volts is applied to this resistor and applied to this resistor. So this is how this is different from what we just did previously. The voltage across this resistor is 6 volts. The voltage across this resistor is 6 volts. So I'm going to try to, before we actually solve, I'm going to try to summarize here. We are talking about a parallel circuit, okay, and the voltage drop across each resistor is the same, okay, whereas the current, sorry about this messiness, the current is split. Split meaning part of it goes here and part of it goes here. And let's compare that to this situation. Here we had a series circuit, and in the series circuit the current through each resistor was the same. Okay, we had 1 amp and 1 amp. Those were the same as the total current through the circuit because the current had to pass through both. And because of that, the voltage was the thing that was split between the two, meaning the 6 volts, part of it was used up here, part of it was used up here. 2 volts plus 4 volts equals 6 volts. Aha! Okay, so I think this is going to be really helpful. You might want to write that down in your notes, okay? And compare that to the parallel circuit, which we're looking at here. Alright, so the voltage across each resistor is the same, 6 volts and 6 volts. Current is going to be split. Here's how we figure it out. Use Ohm's law, V equals IR for this situation, and use Ohm's law, V equals IR for this situation. Let's zoom and say Ohm's law, 6 volts, current, resistance, 6 divided by 4 is 3/2, which is 1.5. Okay, so the current through this resistor is a 1.5 amps. Let's predict. If we know the total is 4.5 amps and 1.5 amps goes through here, does it make sense that and your brain, the gears are turning, I can hear them. Does it make sense that the current through the other one would be what? Yes, you guessed it, 3 amps. Let's triple check just to make sure. V equals IR. We know the voltage across that resistor is 6 volts. We know the current is I. We know the resistance is 2. Holy moly. 6 divided by 2, 3 amps. Wow, it works. So the current through this resistor is 3 amps. Current through this resistor is 1.5 amps. Together, they add to 4.5 amps. Whoa. Alright. That was deep. So, we found in summary, we found the equivalent resistance of the circuit. Remember, I used this for parallel. From that, we used Ohm's law to find the total current through the circuit. We then used what we know about parallel circuits and said, well, I know the voltage drop across each will be the same. So then we can zoom in and find the current through this resistor and the current through this resistor. Alright, we're going to stop here and then look at 3 and 4 later.